This is the solution to number 4 on the 2013 AP Calculus AB exam. Okay, so we are looking at the graph of f prime, and we are told that we've got horizontal tangent lines at x equals 1, at x equals 3, and x equals 5. And then we've got the areas of each region labeled in the figure. And then we've got this little piece of information that f of 8 is equal to 4. So for part A, we're being asked to find all our values of x for which our function has a local minimum. So we know f has a local minimum if f prime changes from negative to positive. And that's happening right here. F prime changes from negative to positive, which means that f changes from decreasing to increasing. So we have a local minimum at x equals 6. So for part A, we'll say f has a local minimum at x equals 6 because f prime changes from negative to positive at x equals 6. All right, for part B, determine the absolute minimum on 0 to 8. So what are our candidates? Let's see. Here our derivative is positive, then negative, then positive. That means that our function is increasing, decreasing, and then increasing again. So this means that the absolute minimum could be occurring at x equals 6 or at x equals 0 at this endpoint. All right, so part B. We're going to say that we're going to take a look at x equals 0 and x equals 6. So let's start with the endpoint at x equals 0. What we're going to do is look at the integral from 0 to 8. We know, using the fundamental theorem, that this is f of 8 minus f of 0. Now we'd like to know what f of 0 is. And we know that f of 8 is equal to 4 because they gave us that information right up here in the directions. Now for the integral from 0 to 8, we're going to take a look at our areas. So the integral would be 2 plus 6, which is 8, minus 3, which is 5, plus 7, which is 12. So the integral from 0 to 8 is equal to 12. So that means that f of 0 is 4 minus 12, which is negative 8. Let's do the same thing to check out x equals 6. So now instead of going from 0 to 8, we'll go from 6 to 8. We know that this is f of 8 minus f of 6. Again, we know that f of 8 is 4. We're looking for f of 6. And the integral from 6 to 8, let's see, here's 6, here's 8. That integral is equal to 7. Which means that f of 6 is equal to 4 minus 7, which is negative 3. So since negative 8 is less than negative 3, we can say the absolute minimum of f on our interval is f of 0, which is equal to negative 8. And now we're ready for part C. On part C, we're looking at our open intervals. We've got to find open intervals between 0 and 8, where f is concave down and increasing. So let's think about this for a second. we know that f is increasing if f prime is positive. And then we know that f is concave down if our second derivative is negative. Now all we're given here is the first derivative. So we can say that if the second derivative is negative, that means that the first derivative is increasing. Or not increasing. Let's try that again. The second derivative is negative, then the first derivative is decreasing. So we want to look at our graph and see where the derivative is positive and decreasing. So that seems to be happening between 0 and 1, and then again from 3 to 4. So we'll write that down, and we'll say f is concave down and increasing on 0, 1, and then from 3 to 4, because f prime is positive and decreasing. On these intervals. Okay, so that's it for part C. We found the intervals and we explained our reasoning. And now we're up to part D. We've got this new function g of x, which is f of x cubed. We're given a function value for f. Find the slope of the line tangent to the graph of g at x equals 3. All right. The slope of the line tangent. So we have g of x. Let's find g prime of x. We'll use the power rule and have 3 times f of x squared, but then we have to use the chain rule and multiply by the derivative of f, the inside function. Then g prime of 3 is 3 times f of 3 squared times f prime of 3. And we were given some of this information. Let's see. F of 3, we were told, is negative 5/2. And f prime of 3, we can get up here. Here's f prime. F prime of 3 is equal to 4. So we have 3 times 25 over 4 times 4, which leaves us with 75. So the slope of the line tangent to g at x equals 3 is 75.